Luke, how's one of my favorite electricians?
Doing great, doing great.
It's great to have you here on the program. Thanks for joining me. Hey, a question's come in to the program about circuits, electrical circuits. Can I ask you some questions?
Yeah, absolutely. Shoot.
Yeah, someone wanted to know, can you explain the process of installing a new electrical circuit? And before you do that, why don't you explain what an electrical circuit is?
Sure. So a circuit is going to be it'll be one wire coming from the breaker, and
Hmm.
newer ones have both wires protected from the breaker. But basically, you got power coming in, and then it goes through a load or whatever they're trying to control. It's called a load, and then it goes back to your neutral system. So that's one circuit. It's basically power in and then returning back to a neutral or ground.
Yeah, and it's important that that circuit be broken when appropriate. How do you break the circuit?
Sure. So there's convenience ones, like if it's a lights, you don't want to have to turn off a circuit breaker to turn off your lights in your living room. So we'll have switches, and
Yep.
they basically just turn it off and on. For like AC units, there'll be disconnects where someone is working. They'll be able to safely, like where they're working at, they can see the disconnect. They pull the power there. So that's one way of breaking it. And then at the breaker panel itself, that does a little bit more. It actually protects the wiring, the amperage of it. And so if it gets too hot or it goes too much, pulls too much power and has the potential of getting hot, it'll break it that way. So a circuit breaker.
Yep. Hence the name,
Yep.
the circuit breaker. It literally breaks it. A lot of people hear about circuits and they know what a circuit breaker is. I think a lot of people consider that a master switch to those outlets or that chandelier or the refrigerator. It kind of is for that circuit. So a circuit basically is electric wiring in a specific location on that panel, right? That's the circuit. It has a specific breaker for it, correct?
Yeah. Yeah. And it'll go to an appliance, kitchen, a different location, but that one circuit is controlled off of that one breaker, and the wiring to it is only good for what the breaker is sized for. So it'll actually protect the wirings if it gets hot.
Yeah, look, how do you know as an electrician you need to add a new circuit versus adding something to the circuit? So, for instance, a homeowner calls and says, "We would like another outlet or two in this room." Can you just add an outlet, or do you have to do some testing first to determine whether or not it can handle the load?
Some people will just add an outlet, but that can cause problems on the house. The standard practice that most electricians should be doing now is they're going to determine what are they running on this. Does it pull a lot of power? Is that circuit able to handle the extra power that's added to it? A lot of times it can. It's might be a flat screen TV and they're just adding a plug, but it's not going to be totally fine to do that a lot of times. But you put a certain tester on it, and you can put it under load. You can put that circuit under load, and it'll tell you the voltage drop. And if you have a significant amount of voltage drop, then that tells you that it's at capacity. So, and then sometimes some manufacturers, like for a lot of the really cool, like instant water heaters, instant heat water heaters, most of those, the manufacturer themselves want it on a dedicated circuit, and it may not pull much power. And a lot of electricians will say it doesn't pulls 2-3 amps for this because it's ran off of gas. And they're like, why do I need to put it on a dedicated circuit? Well, the manufacturer might want it on a dedicated circuit. So you need new wiring from the breaker panel all the way over to that space. And their reasoning is they don't want other interference messing up the electronics. So those are the different, it depends on what you're pulling, what you're powering, and then also what the actual equipment is, what if they want it on a dedicated circuit, or can it be added to any general use outlet. So definitely has to do a little bit of research, tests, make sure that we're not compromising the system.
Yeah, if you're going to be plugging in a toaster oven or a blender, that's going to draw a lot, and that may be too much. But I'm just thinking, if you plug in a lamp or add an outlet to plug in a new lamp, and it was originally designed, the circuit was designed for an incandescent average lamp of 100 watts, but now you're only doing an LED, you're probably pretty good because it's drawing less than it did to begin with.
Yeah, totally agree. And so, yeah, it really depends on what you're trying to run and what you're trying to power. And sometimes they're just for, hey, I'm always over in this area. I want something to charge my phone, so I'm going to add a plug there. Most of the time, it's not going to change the voltage. It's not going to drop any power. It's not going to cause any heat. Most of the time, it can totally be added, but you do need to check it and make sure that you're not making, adding any complications.
Yeah. And by the way, for everyone listening, this is not something you do yourself. You hire a trained, licensed, insured technician in the electrical business. That's what Luke does at Cool Hand Electric. It's important. Also, do not open the panel's panel. You can open up the door if you have to flip it, but do not take that panel off on the inside, because now you're exposing your body to all of that power, and it's a lot, and it could literally kill you.
Yeah.
Right.
No, you're absolutely right.
So be very careful. Luke, as always, thank you so much for joining me today on the program. I appreciate it.
Appreciate it. Later.